Welcome to day 23, where we will be diving into file handling and object-oriented programming. Today, we will explore how to read and write files using objects, as well as the concepts of serialization and deserialization. File handling in object-oriented programming, or OOP, involves reading from and writing to files using object-oriented principles. This process allows you to parse data between program executions, making it possible to save complex objects and later retrieve them, even after your program has ended. Two key concepts in file handling are serialization and deserialization. Serialization is the process of converting an object into a storable format such as text or binary. Deserialization, on the other hand, is the reverse process, converting that stored data back into an object. Common formats for serialization include JSON, XML, and binary files. Serialization and deserialization are essential when it comes to saving and loading object data. Serialization converts the object into a byte stream or text format so it can be easily written to a file. Deserialization reads the byte stream or text back from the file and reconstructs the object, allowing you to use it as if it had never left your program. When writing objects to files, the object must first be serialized into a format that can be saved. This serialized data is then returned to a file. In real-world applications, this can be useful for storing user data, configuration settings, or game progress in formats like JSON or binary files. Here's an example in C++ of how you can serialize a student object and save it to a text file. We defined a student class with attributes like name, age, and roll number, and then we serialized those attributes to a file using the serialize method. Just as we write objects to files, we can also read them. To do this, the data stored in the file needs to be deserialized. This process converts the stored data back into an object that can be used in our program, making it possible to restore program states or load user data. In this example, we read from a file and deserialize the data into a student object. The deserialize method reconstructs the object by reading the stored values from the file. After deserialization, we can access the student's detail and use them in our program. For the exercise, we will create a program that allows us to save a list of students to a file and later load it back into our program. This will involve serializing and deserializing a collection of student objects, enabling us to store and restore data across different sessions of the program. Here's the solution outline. We first defined a student class with methods for serialization and deserialization. Then we create a student list class to manage multiple students. This class will have methods to save the list to a file and load it back. Finally, we implement these functionalities in the main program. Let's walk through the code. The student class handles the serialization and deserialization of individual students. The student list class manages a collection of students providing methods to save the list to a file and load it from a file. The main function demonstrates how to add students, save them to a file, and later load and display them. To summarize, serialization allows us to convert objects into a storable format, while decentralization allows us to retrieve objects from that format. File handling in OOP makes it possible to parse data, ensuring that objects can be saved and restored even after a program ends. File handling is a crucial aspect of many real-world applications, especially when you need to maintain object state or save user data. By using serialization and deserialization techniques, we can easily store and retrieve data, making our applications more robust and efficient.